Right, so we're going to be doing the area of different shapes. So I've already gone ahead and highlighted the different formulas, and also just kind of quick little notes on how you can change how you write it if you so choose. So the first one is area of a parallelogram, and it's just base times height, so whatever your base is times whatever your height is. And sometimes you might have to calculate this, just kind of depending on what you're given, so just make sure you have an actual base and actual height. For triangles, it is 1/2 base times height, which is down here if you see it. And you can also write that as area is base times height divided by 2. And again, you're looking at, is it our actual base and does it give you my actual height? For trapezoid, you add your two bases together, and your bases are the parallel lines. Multiply it by the h and divide by 2. So if you notice, kind of like the triangle, you can also write it as your bases added together times your height divided by 2, or you can also just have it multiplied by 1/2. So either one, they both say the same thing. For rhombuses and kites, your area is 1/2 times diagonal 1 and diagonal 2. And again, you can rewrite it as area equals d1 times d2 over 2 as well, if you prefer. For circles, you might have to have some calculations with circumference, so we went ahead and gave those to you. And then your area for a circle is a equals pi r squared. So just a couple memory things with those, if you need them, is if you know that like your units are squared, then you know that your area formula is going to have the squared because your units are also squared. That's just one way that I remember it. Another way that you can remember it, if you like pie itself, is that chocolate pie is delicious, C equals pi RD. Apple pies are 2, A equals pi R squared. So if you like either of those, feel free. So then area of a regular polygon is 1/2 times your apothem times your perimeter. And just like triangles, you can write it as AP over 2 instead. But that little a, notice it is little, is your apothem, which is this over here. So it is from one side of the shape up to the center. And then the perimeter, you might have to actually multiply however many sides you have times your side length so that you can figure out what the perimeter is. So to actually use these now, oh, I forgot. Sorry. So real quick, just naming the different shapes. If you remember it, awesome. If you don't, that's fine too. But 3-sided is triangle. Notice tri is your prefix. Quadrilateral is 4. Pentagon is 5. Hexagon is 6. Sept and hept both represent 7, so it's either a septagon or a heptagon. One's Greek and one is Latin. Then you have octagon, nonagon, and decagon. And I don't know about some of you, but I have been spelling octagon as Octogon, and it's actually OCTA. So if you've been spelling it right this whole time and I told you otherwise, I'm sorry. I've learned my lesson. So to actually do this, if we are doing area of parallelogram, that formula is base times height. And so if we look at this, we have a base right here, which is 11. So we know area equals 11 times height. But unfortunately, if you notice, this 30 is not a height because it doesn't represent how tall this is. And 34 isn't a height because it's that side length. So that's not going to help us very much. But these are going to be helpful because my height is right here. And if you notice, I have a right triangle that's occurring right in here. So because I have that right triangle, this 34 that I have on this side is also going to be on this side. So then to find my missing length, I'm just going to use Pythagorean theorem. So we have a squared plus 30 squared equals 34 squared. So that would give us a squared plus 900 equals 34 squared is 1,156. And when you subtract 900, you get that a squared equals 256. And then we take the square root. So then a equals 16. Okay, and this is our height, or our, sorry, No, it is our height. I'm sorry. So if you had preferred to like use h instead of a, that's totally fine. But then 11 times 16 is, 16 is 176 millimeters squared. Okay. For a trapezoid, the formula is a little bit uglier, but again, you choose the way that you like to see it. So area for this is going to be 1/2 times base 1 plus base 2 times h. So looking at this, I have my bases, and I already know what they are, and I have my h, which is great because now I have all the variables I need. So sometimes you won't have to calculate anything. You can just plug and check. So a equals 1/2. Base 1 is 11 plus base 2 is 17 times 7. So then 11 plus 17 is 28. So half of 28 is 14. So then 14 times 7, that looked like a subtraction for a second, is 98. And that would be feet squared. Okay. Let me draw myself a little line. All right. So for this one, we don't have a picture, but we do know it's a kite, and it has diagonals of 12 and 8. So if you remember the formula, it is 1/2 times diagonal 1 times diagonal 2. So because we already know our diagonals, we'd have area equals 1/2 times 12 times 18. And if you type it into the calculator straight away, that's fine. Half of 12 is 6. So then 6 times 18 is 108. And this is going to be inches squared. Again, if you were to just type this part into the calculator where it has the 1/2 times 12 times 18, that is totally fine because you will still end up with that 108. But if you're like me and you want to simplify a little bit, then you probably might have that step in the middle. So with this, I have actually changed this to circle in the new document, but obviously my copies are all messed up now. But area of a circle, remember apple pies are delicious also, so R2. So because it's R squared, right now this diameter is 6 inches, so because I'm only going halfway, I know my radius is just 3 inches. So area equals pi r squared would be pi 3 squared. And sometimes we're going to ask you to leave your answers in terms of pi, and sometimes we're going to want actual values. So this would be 9 pi, or 9 times pi in the calculator is 28.27. And this is both inches squared. Okay. Number 5, you have to be really careful because I actually messed this up in my other classes, so you might have gotten wrong information. But when we draw this, we are finding the area of a 30, 60, 90 right triangle with a height of 4 inches that's across from the 60. And really, it's this across from the 60 that you have to be careful of because that is telling you, since it's across from the 60, that 4 inches should be my long side. So because it's the height, I'm going to draw my long side being the height. This is going to be 60 degrees. Oopsie. 60. And then we know opposite of the 60 is 4. So if you were in blue 1, blue 3, or blue 4, you might have missed if you were in blue 4. What we realized in blue 4, because we used trig, is that if we used the shortcut way because our picture was wrong, it messed up our answer completely. So this long side with 30, 60, 90s is x square root of 3, and this short side is x. And if you're watching this and you're in one of those classes that got the wrong information, I'm sorry. But we had originally labeled it like this and said that this was x and that this was x squared root of 3, but that actually messes it up. So we should be using this purple way. So sorry for the wrong info. We're fixing it now. So because I know my long side is 4 square root of 3, if I want to solve to figure out what my short side is, I would do 4 square root of 3 equals x. Or sorry, not 4. 4 equals x square root of 3. I don't know what my brain did just then. But then we divide by the square root of 3. And you notice that would give us x equals 4 over square root 3. So when we rationalize, we multiply by the square root of 3, which makes it 4 square root of 3 over 3. So by solving this, now I actually do have my height and base, which I forgot to write. Your formula is 1/2 base times height. So then when you're doing this, since it's an ugly fraction, and actually let me pick a just completely different color, we would have area equals 1/2. My base is 4 square root of 3 over 3, and my height is 4. So then when we multiply straight across, we'd have 4 square root of 3 times 4, which gives us 16 square root of 3. And then 2 times 3 is 6. And looking at this, we can simplify a little bit. Even though we can't completely get rid of the denominator, we can divide them both by 2. So this would be 8 over 3. So then my area is going to be 8 square root of 3 over 3. Okay? So for number 6, this is a regular polygon, and it has 1, 2, 3, 4, 5, 6, 7, 8 sides. So for a regular polygon, it is 1/2 apothem times perimeter. So looking at this, we have 8 sides. So we have area equals 1/2. My apothem is 18.1. And then my perimeter is going to be 8 times the length, which is 15. And 8 times 15 is 120. So then multiplying this all together, 120 times 18.1 times 1/2 or divided by 2, whichever way you see it, gives you 1086, and this is millimeters squared. Okay. Notice again the apothem, is this length right here. So that's where that number came from. And then that 120 came from 15 times 8 to get that 8 times 15. Let's circle it so it looks different. Okay. So moving on, rhombus with the diagonals 27 and 56. You don't have to label the picture unless you want to. But that area formula is 1/2 times your diagonals. So in this, we'd have 1/2 times 27 times 56. And you can just type that straight into the calculator. So 1/2 times 27 times 56 is 756 feet squared. Okay. For a regular octagon, we have our formula is 1/2. Probably help if I could write the numbers. 1/2 A times P, and I should make that a capital P. By the way, notice that you have 2 A's in this form, or sorry, why did I put it over there? You have 2 A's in this formula, so just make sure that you're careful that you're using uppercase and lowercase. So because of this, let's see, we know that the apothem is 6 meters, so we have 1/2 times 6. And then for my perimeter, my side length is 5, and this is an octagon, which tells me it's 8 sides, so 5 times 8 is 40. So then when you multiply everything together, you get 1/2 times 6, which is 3, and 3 times 40 is 120. Okay. For number 9, with this trapezoid, notice now we're given the area and we are looking for B2. So if you write the formula for a trapezoid, it is area equals 1/2 times your bases added together times your h. So looking at this, we just fill in what we know. We know that the area is 231 millimeters squared. We also know that base 1 is 23 because it's right here, but we don't know base 2, so we're just going to leave it. And we know that our height is 11. And for some of you, it might help you if you actually put, like label your picture with what variable represents the length. That way you kind of keep track of what's what. So to solve this, first I want to take care of this 1/2 because I don't really like seeing it. So I'm going to multiply both sides by 2. And when you do that, we get 462. 1/2 times 2 cancels out. And then you have 23 plus B2 times 11. And even though it might be tempting to subtract because subtraction makes life easier, you actually have to divide first by 11, because if you don't, then you're breaking the order of operations. So 462 divided by 11 is 42. So we have 42 equals 23 plus B2. So then when we subtract 23, we get that B2 is 19. And because this is a length, it is just 19 millimeters. It's not squared or anything. Okay? Okay. So for number 10, oops, I didn't write it on the line. 19 millimeters. So with a kite, we know that in the middle where these meet, this is a right angle where they meet. And we also know that this side is congruent to this side, and this one is congruent to this side. So by knowing that, that will actually help you find the area for this. So if we want to find x, we have a right triangle, right? We're looking at this right triangle. And really, we're trying to find the full length. So looking at this, we know that this side is also 29 inches. Okay, and then, sorry, this 28 in the middle messed me up. And then this is 35 inches. The 28 corresponds to that, this piece right here. Boop, 28. Okay, so since we know that that is 29, we have to find x, and I don't know what that piece is. So I'm actually going to pick a different triangle because I didn't realize that at first. So we're actually going to look at this triangle because I have two sides that I can look off of. I have this 28 and I have this 35. So doing the pink, and I'll put a little pink box, that way we know what we're doing. We have one leg and and our hypotenuse, so we would have a squared plus 28 squared equals 35 squared. So then a squared plus 28 squared is 784. And 35 squared is 1,225. I'm actually going to write this so it looks like a 35 square. There we go. So then when we subtract 784, a would be a squared is 441. And then when you take the square root of 441, you get that a equals 21. So now, which technically this was y, so if you want to write that y equals 21, that's fine. But we now know that that is 21 inches. So now that we have that piece, now we're going to find what is x. So now I have those two sides of the triangles, and I'll highlight it again. And actually, let me get rid of this triangle. So we'll do this one now, because you notice we have two sides. So looking at these two sides, we have a leg and a hypotenuse again. So a squared plus 21 squared equals 29 squared. So then 21 squared is 441. And 29 squared is 841. So when we subtract the 441 from 841, we get that a squared equals 400, which is 20. And again, if you want to use the letters they gave you, then x equals 20. Okay, so then this really is like a puzzle, because I was secretly hoping that these bisected each other, but they don't, unfortunately. So then to find the final length, this one's the doozy, then you're looking at this triangle. And again, you have two sides. So kites, if they don't give you the diagonals, are kind of a pain. But looking at that, we have our side is 20 squared plus b squared equals 29 squared. And so 20 squared is 400 plus b squared equals 29 squared is 841. So then when I subtract it, I get that b squared equals 441. So then b equals the square root of 441, which is just 21. Okay? So I guess with kites, they do kind of have similars. So looking at this, you're going to have to find the lengths of the full side. So this full side is 20 plus 28, which is 48 inches. And then, and we'll use a different color, we'll do red. For this one, it's 21 plus 21, which is 42 inches. So then, plugging it into the actual formula, which I know some of you are probably like, oh my gosh, we're still not done. But we have area, area equals 1/2. Diagonal 1, we'll do 42 times 48. So 42 times 48, and then divide by 2 is 1008. And that is inches squared. Okay. For a circle, we didn't draw it, but we can. So in order to find the area for a circle, remember it's pi r squared. And they tell me that circumference is 22. So if you recall, with circumference, it is 2 pi r. So if I have 22, to find my radius, or 22 pi, I'm sorry. To find my radius, I just have to solve. So we're going to divide by 2 pi. And when we divide by 2 pi, the pi's go away, and 22 divided by 2 is 11. So my radius is 11. So then area equals pi times 11 squared. And again, your answers may be in terms of pi. It may also just be round to the nearest hundredth. So 121 times pi is 380.13. And these are both, we don't have any units, so this is units squared. Oops, units squared. Okay, is 1/2 times the apothem times the perimeter. So to do this, we have a pentagon. So we have 5 sides. And we know that our apothem is going to be this length right here. But if you notice, the only thing we know is 8 centimeters. So we're actually going to have to do some math in order to be able to get this. So easiest way, you have to use your imagination a little bit, but we have a triangle that we can form right here. And in order to find this angle in here for the full thing, we would have to do 360 divided by 5. Which would give us 72 degrees. Now, we really only care about this one side. So I'm going to redraw that triangle right here. This is going to be our apothem. And then this side is this bottom side is half of your length. So it's going to be 4 centimeters. And then this angle up here is going to be half of this angle. So half of 72 is 36 degrees. So then you're going to be using trig. We have opposite and adjacent. So that is tangent of 36 equals opposite over adjacent. So then, through some math magic, you multiply by a and then divide by tangent of 36. So you have tangent of 36. So 4 divided by tangent of 36 is 5.5055. And I'm just going to go out to 4 decimal places. So then when we multiply, we're going to have area equals 1/2 times our apothem, which we calculated to be 5.5055, 0.5055 times the perimeter, which is going to be 8 centimeters times 5 sides, so 40. So then 5.055 times 40 times 1/2 is 110.11, and this is centimeters squared. So hopefully that helped you. If you have any questions, just let me know.